Hello everyone, and my name is Ian. I'm a senior lecturer in High Performance Network Group in the University of Bristol. Today, I'm very glad to have this opportunity to present my group of recent research about machine learning applications for 5G and beyond. Here, I would like to thank all the contributors to this talk and also the support from 5G Clarity Project. So, my talk will start to review deployment status of 5G networks, and then I'm going to introduce the novel networking concept in 5G and beyond. And then I will discuss our recent exploration of deep reinforcement learning for 5G and beyond. Then I will conclude my talk. So if you look into the current 5G rollout and the latest survey and show that 5G have big potential to contribute about $8 trillion to global GDP by 2030, and especially in different industries. And by end of 2020, there are already 45 countries have 5G deployments, and still currently the real promise is in the enterprise. And now more and more people talking about the 6G and 5G beyond, and this is really a big opportunity to carry on industry and also research. So, and the research will be more interesting from the networking concept. And so there's several novel networking concepts introduced in 5G and beyond, and let's review one by one. And all these novel network concepts actually make the 5G networks be flexible and also require more challenging for management. So firstly, it's a service-based architecture. So service-based architecture, if you look into the figure, the different network function, the service we can deploy the different network functions and services. So with this SBA, and they can deploy multiple network services, either by request response or subscribe notify model, and we can connect them with command control protocols such as HTTP based API. And with this service-based architecture, actually we can deploy the full 5G networks. So the 5G network, if you look into here, we have from the access network, the RAN, and also the different non-3GPP gateways, and then we can have the UPI function and different place, edge, regional, and central. And this is most for the user plan. And so they're on top for the control plane and the different functions, and also deploy and the services. And also you notice there the MAC system, and this is all run and the services. So with this service-based architecture, we are really fully realizing the potential of 5G. So moving to software and cloud-based open platforms. And secondly, the networking element. So if you see here, all the key elements in 5G core are cloud native. Yes, they can run on cloud and different computing resource. And also this kind of architecture, they allow automation and programmability, because all these key functions are network functions, actually network function run on open platform. And also this architecture to better support the possibility for diverging architecture for new services. So this is one example. You can deploy 5G deployment example, and you can deploy access network and the user planes with a different function and different scale, and also in the control plane you can deploy the different functions, and based on your requirement. It really brings a huge flexibility and programmability in 5G core deployment. So this is SBA based architecture. Another thing, if you look into RAN, there also we know the 5G and 5G new radio, multi-band, multi-radio, and more importantly in 5G, we are talking about more deep integration with other access technologies, such as Wi-Fi and Li-Fi. They're using licensed spectrum. So to integrate them, and they need to integrate firstly There are the ongoing development function, the non-3GPP ain't working function. So they can deploy that, they can integrate that, and also on the traffic, they have the access traffic stirring and switching and splitting to manage this. Also, there is the ongoing research about multipath TCP to aggregate or to split all this access resource, and also the dynamic spectrum sharing to allow 4G to using the 5G spectrum, and also with this multi-access technology available, deep integrating the 5G, and the UE, the user plan, the UE needs to choose can choose the best access technology or choose different paths. All this is making it more flexible, but more also very challenging to manage that resource efficiently. So this is the RAN access time. We have multiple access technology, and if you look into the RAN network, actually we are talking about function split. And this is on top is a tradition, it's a 4G solution. We have the EPC, the 4G core, and the BBU, the baseband unit to process the signal, and the remote radio head. We have the front haul. So this is the common cloud RAN architecture. And in 5G, actually, we are interested is to split the BBU functions and to different elements. So have the RU and DU and CU, radio unit and DTP unit and CU unit. So we have the front haul, and also we have the mid haul and back haul. And the CU-DU split, and this is very flexible. That means you have different options to split that. So this is, if you look into the split, and there is a CU user plan, CU control plan, and DU and RU. And you can choose actually the different, based on your requirement, the different scenario, to choose different function split for deployment. So this different option, what meaning for these different options? So this is based on, you see there the different options. It's just to split from antenna to data, and all these functions you can split with different options to split on different place, yes, to different unit. So this is really make very flexible scenario for RAN function deployment, and also very important is all this RAN function RU, DU, CU can be virtualized. They can run on commodity. They can run on commodity servers, so allow fully programming in RAN. So, and also there's OpenRAN define this common interface to integrate these different functions. So it really make the RAN very flexible. So another concept is virtual network function chain. So this is the development, the traditional network applicants, for example, the firewall, the NAT, all this aids need specific hardware, but make it virtualized. That means we can run this function on standard servers. So it makes this network function virtualization. That means we can choose, we can decide where to deploy and what the scale of the function. So that will make the network service development very flexible. So this is called a service chain, and for one service, and you can deploy the different functions at different places based on the available resource and your requirement. So the virtual network functions can be deployed on the cloud other computing resource. So this will make really a deep integration of networking and computing. And also with this, it's a very big challenge to deploy this VM chains in on-demand and optimized approach. So the last one is 5G end-to-end slicing. And we already know that in the beginning of 5G, we deploy multiple scenarios with different networking requirements, the quality service, latency, reliability, and so using the end-to-end slicing to provide this thing, to provide these different networks. So this is very challenging. The challenge is to create an end-to-end slice efficiently. So this is all the novel concept in 5G. And if we pull them together, this is the one, the 5G network architecture we have proposed in 5G Clarity project. So if you look into the infrastructure stratum, the device, we have multiple access node, and also RAN class can run the RAN function and deploy the RAN function, and the transport network connect to the edge, and also the 5G core. And on top, this is for the networking element. We're talking about integrate different access technology. We're talking about different telemetry system, and also the 5G core deployment. And also there is a management orchestration platform. So on top, you will see we need an AI engine to using AI to manage this. We know the challenge. We recognize the key challenge introduced by this new concept. So we need the AI technology to manage that, and also the intent engine try to understand the requirement and turn this intent to the network policies. So this is full 5G network architecture. If you want to know more, you can go. If you want to know more about this, and you can go to the 5G the project website, 5gclarity.com, to check more detail. So this is the novel concept introduced in 5G, and now we want to know this the flag scenario, deployment scenario, different function options for function split, and for network management. All this is very challenging, and so we will talk about our explanation of machine learning for 5G and beyond. So if you want to do machine learning, you want to do you need the data, and so I want to start to introduce our 5G UK testbed and also the data lake development, and then talking about our two explorations. So this is the 5G UK testbed, and this is if you see this map, we have Smart in the Lab, that is our lab, and also we have the 5G access RAN deployment and in Bristol, and the different museum, Amshed Museum, and also this is with Curious Museum and Milliman Square and the Watershed. So we have the 4G and 5G deployment with licensed bands. So the 4G solution based on Nokia solution, and 5G is based on Celeron and the Open 5G as it's also part of the 5G Clarity project. So if you look in more detail and really look into that, we using one example in an Amshed Museum. So we want to see they're using the 5G serve network 5G connection to enhance the tourism experience, and with the robots and with the cameras, all these things. And so this is the RAN side deployment, and for the core we deploy and the Smart in the Lab. So we have the 5G core functions and also the management. So this is one playground we want to see whether we can use this for running the 5G now, one different AI application or different 5G concept. So, and also with AI, we need data. So we have this end-to-end monitoring and data lake. So that means we're going to collect the data from different applications and different access points, and also the UE and also other applications, all collect the information to a data lake. So we can processing and to using to support for the 5G for the AI applications. So you can look into that. We are able to measure all the parameters for different access point, Wi-Fi and Li-Fi and 5G, and this is allow better decision, or if you want using this information to make intelligent choice to configure optimize network. So with this, we want talking about the first solution is UE side to access the optimization and task offloading. So this is UE. We have multiple. We have them on UE side. We have multiple access resource. You can access to different radios, and also you have the access to different computing resource. So on the UE side, we deploy using we're using the DeepQ network based reinforcement learning to using the real-time information to optimize the optimize the access strategy for UE, and also for computing resource, we are looking to the offload compute task to different resources located either in private and public networks. So this is the first system design. Looking to the left figure, so the UE are moving in a place, and they can connect to different access point from Wi-Fi and also from 5G, and so they can, based on the movement, they can choose a different where they can which one is best to suitable, so they can maximize the full network performance. So we're using the DQM network to do that. And also we are looking to the task offloading. So based on the task requirement, so we also can offload this compute task either on UE or you private MAC or public MAC or cloud. So you have the different option, so you can make that choice. To support the research, we deploy the simulation and the training environment. So if you want to do that, you need very large scale deployment and to evaluate. So we're using the NI3 to develop our simulation training environment. So this is the inside NS3, and we define the UEs and also the function, the Wi-Fi access point and the LTE and also the 5G. It's ongoing work to deploy that. So this is APC for 4G for 4G core and also applications. So this is inside NS3, and for the AI application, for the DQM based reinforcement learning, we're using Gym AI to develop that. And to make this interaction, we developed the interface between the NS3 and the OpenAI Gym. So we can train that, we can validate in the watch environment. So this is some preliminary result, and we have the fully interaction between the Gym AI and NS3 setup. And so this is show our training and the loss. So we are still this is still ongoing work, and we want to validate in the real test bed to show this benefit. So this is one research and UE side optimization, optimize access and the task offloading. The second thing is some collaboration work with BUPT, and so this is using machine learning based function deployment and routing. So this is we have this more related to the backhaul services and also the run side deployment. So we have the different function split, CU and DU, and different available computing resource and different place. So we have the network. So we want to, based on the requirement, so we can decide where to deploy this function and where to achieve the maximum performance and save the cost, the power consumption, to reduce the bandwidth. So this is the developed the algorithm for reinforcement learning, and this is you see this is inside inside the algorithm for this DNA network. So this is to estimate state and to update the policy and to generate policy. So this is some result. We have this topology, and then we can based on the traffic request to optimize this and to generate the optimal performance. So we compare this with we compare the performance also with other first phase algorithm or using an ILP model. So we see that this performance very close to ILP model provides the optimal performance. So that means we can, if we consider the run and also the backhaul network together, actually you can optimize the whole network performance. So this work is accepted by GOT recently. So then I will here I will conclude my talk. Yes. So this is we talk about novel network concepts in programmability and flexibility. So in terms of service deployment, network function. So this is really require intelligent policy and strategy to operate a managed network resource. And we believe the deeper integration of networking computing has become a reality and necessity for 5G and beyond networks. And machine learning, especially differential learning, will provide great tool for automated network management in 5G and beyond. So we believe deployment of 5G, deployment of machine learning in 5G beyond is much closer than it happens in other networks. So so that is all my talk, and thank you for your attention. And also here is if you are interested in this area, we have an open call for this special issue, machine learning in the area of computing and network integration. And so the deadline is November 30 this year, and if you are interested, you can contribute. Thank you very much. Thank you for your attention.